Alright guys, because the last video that I created kind of got interrupted by the janitor, I'm going to go ahead and redo number 8 in this video and then go ahead and finish the notes off with number 9. So, if we are going back to number 8 and we're trying to prove this identity, knowing that we can use the double angle formulas, then the side that we want to work with is going to be the right side because the left side is the more simple of the two. So the left side, I'm just going to draw that arrow straight down. Now, this is a secant. Secant is 1 over cosine. We only have sine and cosine double angle formulas, so we know that our end goal here should be to somehow end up with this side looking like a 1 over one of the cosine double angle formulas. So the first thing we need to do is mess with those cotangents and tangents. And the first thing I did was turn them into the sines and the cosines, because I'm aiming for a cosine on the left-hand side. So this is going to be cosine x over sine x plus sine x over cosine x all over cosine x over sine x minus sine x over cosine x. Now what you guys should be recognizing is that those are fractions within fractions with addition and subtraction, and that's just a disaster. So we definitely want to make sure that we are getting rid of that by multiplying everything that you see on top and bottom by these unwanted denominators. So that means multiply by sine and cosine on top, and multiply by sine and cosine on the bottom. Again, doing the same multiplication means that we're going to have just a multiplication by 1, so it doesn't change the value of anything. So, when I do this times this piece is gone, the sines cancel, cosine times cosine is cosine squared. Ignoring this times this, cosines cancel, and I have sine squared. That should be fairly exciting because cosine squared plus sine squared we know is 1 from our Pythagorean identities, so that is going to make a very nice top to our fraction. Now on the bottom, same thing, sines cancel to start with, so I have cosine squared x minus, for the second one, our cosines cancel, so I'm left with sine squared x. And what you should recognize is that this is our cosine double angle formula, and that is our 1, our Pythagorean identity of 1. So I end up with 1 over cosine of 2x, and 1 over cosine is secant. So I have secant of 2x equals the secant of 2x. Alright, so again, pause, rewind, re-listen, do whatever you've got to do to make this make sense to you. I'm going to go ahead and do number 9. And before I get there, I just want to remind you guys that every single homework assignment that you've had that was due while I was out, the answers are on my webpage along with the blank copies of that homework. So there's no excuse for you not having at least something to look at to get you through all of those. I've also posted tonight's homework. It is the last new thing. This double angle stuff is the last new stuff. When I come back, we're going to do your test review, and then you'll take the test. So we'll take some time on that Tuesday and Wednesday that we all come back after President's Day to get that stuff done. So, looking at number 9 next, finish this up. Obviously, looking at this, you should be noticing that the left-hand side is the easier side to mess with, so, or the left-hand side is the easier side, so don't mess with it. You want to mess with the right-hand side. We're going to replace the sine 2x with the sine double angle formula, and from the top you guys should have that that's 2 sine x cosine x. Over 1 minus. Now we need to replace that cosine 2x with something. The problem is we have 3 choices as to what to replace that with. So the one I chose was the 1 minus 2 sine squared x. And that's because I can get that 1 out front to cancel if I do that. So if I do this, then these ones will automatically cancel. And then by default, the 2's are going to cancel, and one of the signs will cancel. So I picked something that's gonna cancel as much as possible. Now, if you didn't know what to do there, try one. If it doesn't work, go back and try a different one. I know that you guys really don't like doing proofs multiple times, but a lot of times that's what it takes until you get comfortable and start seeing some of the patterns that arise. You have to actually do it again and again and again and again. So, I still have the 2 sine x cosine x on top. And on the bottom, 1 minus 1 is 0, and negative 2 times negative, or negative 1 times negative 2 is just 2 sine squared x. So what you should be seeing there is that these cancel. That sign is going to cancel one of the 2 signs. Please remember this is sine times sine. And so I'm left with a cosine of x over a sine of x. And last time I checked, that was contagion. So that is my proof for number 9. Again, if you have any questions, if any of this is not making sense, you have an entire classroom full of other students that somebody is bound to have caught on to what's going on. And if all else fails, write it down. Write down the question you want to ask me. Either send me an email or save it for Tuesday or Wednesday, whenever I'll see you next, and we will go over it. So that is the double angle formulas. Yes, you have to know them for your test, along with the sum and difference. So we are done with new material for Unit 6. Have a good weekend, guys. See you on Tuesday or Wednesday.